Hi, my name is Andrew. I'm an Associate Business Manager here at Maxim Integrated. Today we're going to talk about the MAX16050 and the MAX16051. These are multi-channel voltage monitors and sequencers, and we have them on an evaluation board that our engineer Ahmed will talk about shortly. These are highly accurate voltage monitors and sequencers. They have 1.5% accuracy. They take in a wide input voltage range of between 2.7 and 13.2 volts. And they're also highly configurable. You can configure the sequencing ordering, you can configure the sequencing delay, and you can also configure the reset timeout delay. And all of these features and many more, which we'll talk about and demonstrate to you, come in a small 4mm by 4mm TQFN package. And I'm going to hand it off to our apps engineer, Ahmed, now, and he'll go through a demonstration for us.
Thank you, Andrew. Hi, everybody. My name is Ahmed Ayar. I'm an application engineer at Maxim Integrated. So in today's demonstration, we'll talk about how to set up the sequence delay for these parts, how to bypass a channel during power up process, how to do a reverse and simultaneous power down, and finally, how to daisy chain the MAX16050 with the MAX16051. So if you look at the board, we have two ICs over here. The MAX16050 is over here, and then we have the MAX16051 over here. Both of these ICs are surrounded by a bunch of passive components right over here. And I would like to take a minute to describe some of these components. So the MAX16050 and 51 use a single capacitor from a pin called delay to ground to set up the sequence or the global sequence delay. For this particular board, we have 1200 picofarad capacitor for that value, and that sets up the sequence delay to about 600 microsecond typical. Now we also see some additional capacitors on the board. In some application, you might want to have a different delay other than the global delay, and you can do that with this board, and you can connect a capacitor from set input from a corresponding set input to ground to set extra delay on top of the global delay that we talked about. We have some resistors as well on the board. Some of these resistors are used as pull-up resistors, and we have a number of outputs that are open drain outputs. For example, we have reset outputs, we have fault output, we have over voltage output that is monitoring the converter's output for over voltage fault. We have a RIM signal, which is a bus removal signal. And also we have all these outputs that are connected to the enable inputs of the converters that you want to sequence. And these all require pull-up resistors. In addition to that, we have some resistive divider networks. And in normal application, you would want to connect these networks to the output of the converters, the corresponding set input and ground. And it serves two purposes. One of during power up, the resistive divider would allow the set input to reach up to 500 millivolt before it enables the next converter. So in a way, the preceding channel's set input voltage controls the next output. So that's how the process of sequencing starts. During normal operation, if any of the converter's output overshoots, then in such a way that the set voltage reaches about 550 millivolt, then you're going to get an overvoltage fault for that particular converter. And similarly, if you have an undershoot on any converters, then you're going to go into a shutdown process because of that undershoot.
Great. No, thank you. So how does the jumpers on the bottom of the board, what kind of options do those give the user?
Yeah, sure. So these are mostly configuration jumpers, and I would like to go over the ones that are relevant for this demonstration. For example, if you look at the bottom right, we have 3 jumpers over here. These 3 jumpers connect to the 3 logic inputs of the MAX16050, and the logic level of these inputs will determine the sequencing order for the MAX16050, and it's particular or specific to the MAX16050. This option is not available for the MAX16051. The MAX16051 has only one fixed sequencing order, and that's one of the differences between the two parts. The next jumper that I want to cover is enable hold jumper, and it connects to the enable hold input of the MAX16050. It's a logic low input, and when you pull that pin to ground, it allows the device, through this jumper, it allows the device to hold the outputs to their current state, and ignore any transition on the shutdown or enable input. The jumper next to it is called VP jumper. So in case, and it may be desired that you want to pull up the output voltage to some other voltage other than VCC. Now this jumper will allow you to do that, and you would want to connect the external pull-up voltage to these two posts right over here. Right after that, we have the shutdown input. And again, it is connected to the shutdown input of the shutdown jumper rather, and it's connected to the shutdown input of the MAX16050. And it allows you to pull that input to ground and initiate a reverse power down. All the other jumpers right over here are for the MAX16051, but it serves the same function as I described to you for the MAX16050.
Thank you. And what about jumpers J1 and J2?
These are also for configuration purposes. And what it does, it allows the EV kit to be either in DC to DC mode or demo mode. In DC to DC mode, you would want to connect this EV kit to a real system where you have all these outputs and you want to control and you want to sequence. But in demo mode, which is what we are going to use for today's demonstration, it actually uses the output pull-up voltage and feeds that voltage into the resistor divider that we have for the set inputs, and that's how it's able to sequence from one to the next and demonstrate the sequencing capability of these devices on this board.
All right, cool. Well, let's see a power-up sequence demonstration real quick.
Yeah, sure. So what I have on the screen, as you can see, is 4 channels, which is the 4 outputs from the MAX16050. Let me put this out here.
Take this for me.
So as you can see, I have 4 channels, 4 traces that represent 4 output channels of the MAX16050, and it has, it has a sequence to it. This is channel number 1 coming up. There's some delay between channel number 1 and channel 2, and then after that we have channel number 3, and then right after that we have channel number 4. And if you notice, we have this delay, but it's not uniform, and that is very much pronounced from here to here, which is much larger than what we have between 1 and 2. And that delay is actually is being introduced by the capacitor that we talked about earlier, that you can connect from set input to ground to introduce more delay on top of the global delay that we described. So this is the normal sequencing, or power-up sequencing of the MAX16050.
And so how do you bypass channels during the power-up sequencing?
Yeah, so that's actually very easy with this device. We have a bank of switch on this EV kit, and it's called SW2, and it consists of 10 switches, and each switch on that bank is connected to a particular channel. And if you want to bypass a channel or disable a channel, all you have to do is just go to that switch and snap it from off position to on position. So let me just go ahead and do that to demonstrate that. So if I want to, as you can see, I disabled one of the channels, which is channel number 3. And if I bring it back, it's just going to come back again. So that's how you're able to disable or bypass a channel during power-up process, which could be required for some applications.
Really nice, yeah. And what are the powering down options that we have on this?
Okay, we have 2 power down options. One is simultaneous power down, which is done using the enable input. And the other one is reverse power down. The reverse power down is actually the reverse of the power up sequence. So the last channel that is going to come up will be the first channel to go down. We can do that using the shutdown input. And if I change the setup to get, to trigger on the falling edge, we can see that happening. Now, what you see is a power down, reverse power down scenario on the scope. And you can see that the last channel that came up is the first one that goes down. And obviously, all the other channels are going to follow. And this is reverse power down, and you also see the delay that is there. And also, we have a simultaneous power down as well. So we can do that by, putting the signal on the enable input. And as you can see, this is more like a simultaneous power down where there is no delay between the channels powering down.
Great, great. And as far as putting this into daisy chain mode, how do you go about doing that?
You can also do that with one of the switches on the switch banks that we have on the board, and it's called SW1. It consists of 4 switches and establishes the communication between the 2 parts. And as you can see on the on the diagram, the important signal for this type of operation is the reset signal and the REM signal. Now on this board, we have the MAX16050 coming up first, and then it's followed by the MAX16051 during power up process. So the reset signal that is actually generated by the MAX16050 is going to the enable input as a triggering signal. And on the power down process, we have a REM signal that is generated by the MAX16051 going into the enable hold signal of the MAX16050. And that's where the enable hold is actually come in handy for this type of operation where you have a daisy chain operation. And in this case, enable hold is being held, the outputs of the MAX16050 is being held to their current states, and it does not allow it to power down before the first part, which is the MAX16050, is going to power down. So the reset signal actually in this case would be generated by the MAX16050, which is during the power up process. The reset is actually part of the supervisory function, but is actually being used to communicate in this fashion with from one device to the next. Once the MAX16050 completes its power up process, that reset signal is going to be released and sends the signal to the MAX16051 to initiate this power down. On the way, on the reverse, or the reverse power down, the REM signal is actually holding, as I mentioned, the MAX16050 in hold state. And while the MAX16051 is powering down, the REM signal is going to be low. As soon as it completes its power down process, it's going to be high, and that is the signal that the MAX16050 is going to use to initiate this power down process.
Great, thank you for a wonderful demonstration.
Thank you.
Appreciate it.